Boom! Right. Yes. So welcome to another video in our series, the CSEC AdMaths project. This is the second video in our discussion of polynomials. All right. Polynomials will be very important because everything you'll be doing in AdMaths will revolve around polynomials. Yes, there are other types of terms that you'll also deal with. So for example, you have to deal with surds. Of course, then you'll have to deal with trigonometry, right? And then of course you'll have to do the calculus later, differentiation and integration. But the polynomials is at the heart of differentiation and integration. It is the heart of pretty much everything else, more or less everything you're doing in AdMaths, and it has been at the heart of most of what you would have been doing up to this point. So now that we kind of revised that at the start, now we get into the multiplication of polynomials, which could also serve as a revision for your expansions in your mathematics, right? So remember, in your CSEC mathematics, you would have gotten something like, let us say you would have had something like x plus 7 into x minus 5. You had to expand that, right? Now, that is pretty much as hard as it would get at the level of CSEC maths. So you would have, before that you might have, let us say, you might have something like, let me take some space here. You might have x into x plus 7, or you might have 5 into x plus 7, right? This is your regular expansion, so you know that this would be x squared plus 7x, and you know that this would be 5x plus 35, right? At this stage, you should be familiar with this. We're not even going to spend time discussing that, right? And that is something I want to reiterate where the AdMaths is concerned. Once you're doing AdMaths, once you reach here, we're pretty much taking certain things for granted. So in other words, when we start to talk about polynomials, and we start to talk about expansion, and we start to talk about multiplying polynomials, this is not supposed to be giving you a problem. If it's giving you a problem, then all it means is that you're going back. You have to go back to your CSEC maths and do the relevant revision that is necessary, right? You don't want to be caught wobbling because you're weak in basic stuff like this, right? AdMaths is not something to play with, right? There are people there are a lot of students, right? I had a couple of them myself who would have gotten 1s in maths, and then in the AdMaths they got a 3 or 4, right? The whole point of being here is that the ultimate is that we're trying to get a 1 in AdMaths too, right? But with that as the ultimate, within that context, you want to do the best that you could do. So if your best is at 2, no problem. If your ultimate best is at 3, we could work with that. But of course, the idea is that we're not taking anything less than a 3, right? If your best is at 3, aim for a 2 now, right? And if your best is at 2, aim for a 1. And if your best is at 1, then try and get the best and the highest one that you could possibly get, as close as possible to 100. Is a mentality we're looking at here, all right? Yeah, you'll get a little talking in between too, but all that is part of what we're doing and how we're doing it. So this is the maths. This is supposed to be a given at this point, at the beginning of the AdMaths syllabus, all right? So just a quick revision. Remember in your CSEC maths, if you had to expand this, you would take x and multiply it by that to give you x squared, and then you take the x and then multiply it by minus 5 to get minus 5x. You take the 7 and then multiply it by x, and then get plus 7x. and you take the 7 and then multiply it by minus 5 and you get minus 35. Alright? Of course, you add the like terms together, so you'll get now x squared. Minus 5 plus 7 is 7 minus 5 is plus 2x minus 35. So you see this here, again, that is not supposed to be a problem at this level. Right? So I just want to reiterate that. If you're having problems here, to move from here to here, then fix that as fast as possible, because it only gets more tricky from here. This is add maths, this is not maths. Alright? Nice. Now, in add maths, you might find yourself having to do this. You might find yourself having to deal with x plus 7 into x minus 5 into x plus 1. In other words, you now have 3 linear polynomials, right? Remember we discussed polynomials in the preceding video. Linear polynomials, polynomial of degree 1, degree 1, degree 1. Now, if you multiply 3 linear polynomials, what do you expect to get? These are the kind of things we have to know. Now, you may not have thought of it in these terms at the level of maths. So here now in add maths, we had to flesh out the thing out more. You have 2 linear terms here, x plus 7 multiplied by x minus 5. You multiply those 2 terms together, and what you end up with? You end up with a quadratic. So in other words, you multiply a term, you multiply a polynomial, of degree 1 by another polynomial of degree 1, and the answer is a polynomial of degree 2. So anytime you're multiplying 2 polynomials, the result, the answer would be, the power of the answer would be the sum of the powers of the other 2. So in other words, if you multiply 3 linear polynomials, the answer would be a polynomial of degree 3. Degree 1 plus degree 1 plus degree 1. Alright? And it goes for any other combination of powers that you could care to think of. So, if you multiply, well, let me multiply this out first and then we'll go to the power of 4. Right? So, and you'll see why I do that in a little bit. So, let us multiply this out. Now, the reason why I do this is because we already haven't done these 2. We could then substitute this down here. Good? So we could say that this is equal to, this by this is equal to x squared plus 2x minus 35 into x plus 1. Now, of course, if you in an exam happen to do that, you'll have to go on the side and multiply this out first and then bring it here. I just took it here because I already did it up here. And now you're multiplying this out now. This here is where we move from maths into add maths. You wouldn't have to deal with this in maths. This is as far as it gets in maths. Here now we have a whole quadratic to be multiplied by a linear expression. So let me do it. Now you could do it, you could multiply this by this, or you can multiply this by this. It really doesn't matter. But since we have it like this, I'm going to do it like this just for the sake of the explanation. So this is the same thing as, you take the x squared and then multiply by x, you get x cubed. You take the 2x and then multiply by x, you get plus 2x squared. You take the minus 35 and then you take the minus 35 and then multiply by x, you get minus 35x. And do the same thing with the 1. X squared by 1 is x squared. 2x by 1 is plus 2x. And minus 35 by 1 is minus 35. So you see what's starting to happen here already, right? And this is another place where you start to feel the difference between maths and add maths. In a lot of questions, the add maths, the working will be long. It will be tedious. Right? You hear the kind of vocabulary I'm using because I want to drive home the point. This is not a walk in the park. Right? Yeah, custom right now things in a particular way in maths and taking up a certain amount of space. But watch, you come and add maths and look at the length of that. Right? This in itself is its own mental hurdle that you have to surmount. Right? You had to get accustomed to writing. You had to get accustomed to writing plenty. Right? So there'll be cases where the question wouldn't even be hard. It's just long, and it's just plenty writing, and that alone could tire you out if you're not sufficiently prepared mentally. So in other words, there is a certain level of mathematical stamina that you have to bring to the equation when you make the movement from maths to add maths. Yeah. So we're going again. So here now is where we bring all the like terms together. What do you mean by like terms? All right, x cubed. We only have one term in x cubed. So this is x cubed. 2x squared, and then you have x squared here. 2x squared plus x squared is 3x squared. Minus 35x plus 2x is minus 33x, and minus 35 is minus 35. All right? So you have, and that's it there. So there's one thing that I neglected to mention in the first video, and I'm going to mention it now. And if you want, you could go back to the original video and verify it for yourself. In the constant, the number of terms in our constant is just 1 because it's one constant. So in other words, if the power of the polynomial is 0, you have one term. With the quadratic, with the linear, where the power of the polynomial is 1, you have 2 terms as a maximum. You can have a term in x and a constant. Right? With the quadratic, you can have up to 3 terms. The quadratic, of course, being a polynomial of degree 2. So if the degree is 2, then the maximum number of terms is 3. X squared, x, and then you have the constant. And the same thing goes for power of 3. A polynomial of power 3, the maximum number of terms possible will be 4. From x cubed goes straight down to x to the power 0. And the same thing goes for polynomials of degree 4. The maximum number of terms is 5. From x to the power 4 straight down to x to the power of 0, which is a constant. So in general, and I need to steal some space here now. In general, if the power of a polynomial or the degree of a polynomial is n, then the maximum number of terms that that polynomial could possibly have would be n plus 1 terms, right? And I'm talking like this deliberately because I want to get you accustomed to a certain type and a certain level of mathematical expression, of mathematical vocabulary. All right, this is not a game. All right, so that's x to the power of right. So this is what we got when we multiplied 3 linears. Now, when you move from here to here, you now have a quadratic multiplied by a linear. So in other words, degree 2 multiplied by degree 1, the final answer is degree 3. All right? And if we want to be extra difficult now, and I'm going to steal some space at the top of the board, right? I need to leave those, yeah, I'm going to take this out. I'm going to take this out, and I'm going to remove this. All right? So if we want to be extra difficult and say that, let me see. If we want to be extra difficult and say x plus 7 by x minus 5 by x plus 1 by, let us say, x. minus 3. So now we have 4 linear terms being multiplied by each other. Of course, if you're multiplying 4 linear terms by each other, you expect the answer to be a polynomial of degree 4. Right? So let us see. We could do that by making 2 quadratics, or in this case, we already have this by this by this, which is all of this. So we could then just have a cubic by a linear. So in other words, a quadratic by a quadratic, power 2 by power 2 will give you power 4. 2 plus 2 is 4. Power 3 by power 1 will give you power 4 as well. 3 plus 1 is 4, etc., etc., etc. So using what we already have on the board here, you will have, let's see. We already have this, right? So you'll have x cubed plus 3x squared minus 33x minus 35 in brackets by x minus 3. Now, because the time on the video is running out, operating under certain limitations where the cameras are concerned, but we will fix that just now. We will buy some new equipment and thing. I am going to, what should I do? So I will leave this as a challenge for you to work out, and then I'm going to make a next short video where we just work this out, and that's it. Right? Now, of course, accompanying these videos, we will have questions for you to practice. Right? We get questions. I'll make up questions from textbooks, questions from the internet, and yes, questions from past papers. So I'm going to end this video here now, and in the next video to follow up, we will just work that out, and that's it. You hear the alarm going off there? Right, time to wind up. So that's it for now. Take care, keep good, and look out. We're coming with the next video right after this.